Okay, so as I mentioned earlier, we've cut 2 pieces of 1x1, and we've got another set of 1x1s. We're going to combine copper with brass. And I don't care, I mentioned earlier, I don't care how you put these together. Some people will be very original and just stack them. That was a joke. Some people will actually, offset them so they can turn them into something else later on. So, right, we could do something like that. That's what I'm going to do. And I'm going to take a piece of tape and I'm going to wrap that tape. Now you'll notice I wrap that tape around, but then I come back and I use my nail to really make sure that I'm sticking that down. That is important. If you don't do that, this thing's going to shift. So I really, hold them together really, really well, okay? Like that. All right, I'm going to do the same thing with the other one. Except I may do a different pattern with this one because we're doing 2 samples. Let's do that one like this. Tape those pretty heavily. Just kind of burnish that down so that there's no way. I don't have a lot of overlap on this one, so. Okay, so now that we have that, I'm going to come in and I'm going to put in a dot or 2 where I want my, take this off for a second, where I want my rivets to go. So I'm going to do something like do a rivet there, a rivet there, and then on this one I think I'll do, let's see, how do I want to do that? Maybe a rivet there. Okay, so the first thing that we do is we take a center punch. Right, we're going to drill a hole. So we need to center punch, and we're going to remember that we need to do this on a steel surface, okay? Don't do that against the wood of your table. It'll dent your metal. Now, we talked last class that we need to establish some drill bit sizes, right? So, and we know we're going to put a solid rivet and a tube rivet in the same sample. So, last class I showed you how to straighten a wire, right? So we pulled this in the vise with the draw tongs, and then I cut off the pinched edge, right? So that we would have an accurate read of the size rivet that we needed. Alright, so it looks like a 47. 48 is a little too tight, I think. So we're going to go 47. So I'm just going to write on here 47 so I remember what size to do. And then the tube, and I'm going to provide the tube and wire for you, right? So it's going to be sitting here. The tube is a 33. So I'm going to write a 33 on that one. All right. Now, I have cut some little pieces of wire. These are going to be sacrificial rivets. A lot of times what I'll do is I'll take my pliers and I'll just bend a little head on that so I can get a hold of it easily. So I usually go over there to the drill press with some temporary rivets. All right, now why do I do that? Any ideas why I make these? Yeah, that's one thing I can use them for, to make sure they can fit. But the other thing is that when you're drilling something, okay, if I drill this first hole right there, and then I go to drill the other one, if this shifts at all, and I go ahead and drill it, there's no way I can ever get two rivets to go in there. So what I do is when I get done drilling this one, I take my temporary rivet and I stick it in that hole, okay, before I drill my second hole. Okay, everybody got that? So if I was gonna drill this many rivets, right? You know, you're like, why would you ever do that many, Frankie? Well, you never know. It might be that I'm making I don't know, some decorative element, right? When I drill the first hole, I temporary rivet it by putting a little peg in there, and then I drill my second hole, I put a temporary rivet in, okay? Then I go drill my third hole. Do I need to put a temporary rivet in it? No, I don't. Okay. The reason I don't need to is once you get two things locked in, once I have two temporary rivets, it can't move. It's pinned. Okay. So think about that. Like in the future, if I had 100 holes that I needed to rivet, I'd only need two temporary rivets to make sure everything's held in place. Once those two temporary rivets are in place, there's no way it can shift. There's no possible way. Doesn't matter how many holes I drill in that thing. It can't shift once I get those two pins in. Okay? All right. So that's what those are for. Those are basically for us to shove down in the hole before we drill our second hole. Okay? And we won't need to put a second one in there, but a second temporary, because we're only drilling two holes. Okay? All right. Okay, so let's go over. I think, yeah, let's come over to the drill press, and okay, so I'm gonna pull out a 47. That's the size that we're gonna drill, okay, for that first rivet. Now, I have had students that were gonna drill, you know, they were gonna put a 33 rivet, a tube to begin with from the very get-go. Like that was like, they're not doing the sample. So let's pretend we're working on a piece, we're gonna put in a tube rivet, okay, and it's a number 33. I have had students start drilling with this 33. You can do that, okay? It is possible to do that, but it is better to drill what's called a pilot hole. Write that term down so you know that term, pilot hole. Well, so what a pilot hole is a smaller hole that basically makes it easier to drill bigger holes, and it'll make your bigger holes more accurate, okay? So the easiest way to demo this is to show you with a giant bit. So pretend we're thinking about this from this being a small bit that we've magnified. If you notice, the drill bit has this flat, this webbing, okay? The webbing a lot of students think that the web is what does the drilling. It isn't. It's actually this right here. This face and this face is what does the cutting, okay, of any drill bit. So the moment that these get dull out here, cutting stops happening. If you go over to sculpture, you look through their drill bits, they'll be kind of like this. They'll be scorched, where somebody just like, you know, like whatever size they needed, they just started drilling, okay? And that will burn up the tip of the bit usually, because the bit isn't designed for the tip to make initial contact. What's ideal is if you drill a pilot hole first, okay? So what that does is when you drill a pilot hole, the tip is no longer contacting the metal. It's actually down inside the hole, and it's letting the side faces do the cutting. Does that make sense? So a pilot hole always helps if you're having trouble drilling something. First of all, it's helpful for locating a hole accurately. I've seen students take a 1/2-inch drill bit and just start drilling, and it walks on your center punch because the webbing is wider than the center punch, okay? Like the divot. So it's really useful to drill pilot holes to work your way up to a larger hole. Just make sure you know that. If you don't do that, you're going to hear a lot of screeching from the drill press, high-pitched screech. And so you need to make sure that you drill pilot holes in the future, okay? When I was a student, I would take this to the extreme, okay? I would say, oh, I'm going to eventually drill a number 22. And I would start all the way down here, like, 55 or 52. And I would work my way up, okay? And you don't need to work your way up where you're drilling every drill bit all the way to 52 or to 22, okay? But it does help, to go in small increments. If you're having to drill a large hole, work your way up. Now, typically, I'm going to give you this little tip. If you were going to drill a pilot hole, you could judge the pilot hole size based on the webbing size of the hole that's going to be the final size. So if a 1/2-inch hole is my final drill bit that I'm drilling, I could find my pilot bit should be the diameter of the width of the web. Does that make sense? So those of you that get into drilling holes and you want to know, you really should just do one pilot hole and then the final size. But that's how you base that measurement, is by knowing the webbing size of the drill bit, and then you can use that to determine. So our pilot hole should be that diameter right there of the web. Okay? It's kind of a neat trick to know. Okay, so again, since we're going to be drilling a larger hole, I'm going to go ahead and drill both of these holes with this 47, right? Because the 33 bit's going to be bigger, but I might as well drill a pilot hole while I'm at it. Does that make sense? That's why I went over that. I want to make sure you know that even though we're putting a bigger hole in here eventually, go ahead and drill it with the same size drill bit that you've got loaded, because it'll just act as a pilot hole for us later on, okay? All right, questions about that? Okay. So I've already got that bit loaded. Okay, so block of wood, right? I'm actually going to put a couple blocks. Now, this little sample gets out of control pretty quickly in a classroom this size, okay? People are like waiting to use the drill press and that particular drill bit, because we only have one of those drill bits. And so like people are getting a little antsy, and then people are nervous while they're sitting here, and like it just gets a little angsty in here, okay? So because someone feels like they're being weighted, they're like, oh, someone is behind me in line, they start getting in a real hurry. Okay, I just want to tell you right now, if you're at the drill press, you're in control. You're in control of the pace, and I do not expect you to speed up the act of drilling, all right? You need to do exactly what we talked about. Like if you get into it and you're drilling and things start to heat up, you need to stop and just like take a break. And that person behind you needs to be patient, okay? So just know that the reason that we're got multiple things happening, sawing our ring out, getting all that stuff prepped, is so that you're not like impatient. Because the person here is got some stuff going on where it's like, if this thing lets go, it can fly out and hit them in the face, and it can cut them because it's like two little pieces of metal that are really sharp, right? Luckily the tape helps kind of soften that. But like, I just want you to take your time here, okay? And that's another reason why coming in outside of class to work on this is probably a good thing too, okay? All right. So we're gonna use a little oil. I'm just gonna rub a little bit on the bit to lubricate that. I'll line this up. And you'll notice I'm kind of like pinching. I got my thumb underneath it here, underneath the table. And this will be harder to do because you're going through 2 layers of metal. So you'll get through part way and then you'll be like, oh, cool, I'm through. And then you're like, oh, wait, now I got more to go. And the tape always lifts a little bit, and it kind of wants to shift at that point you get through the first layer. So you have to be careful. All right, and we should be able to take that temporary rivet, and it should be a tight kind of hole, which it was, and I can push that down in there, and now we can drill our second one and know that everything's going to stay in place. Make sure to clean out the flutes of your drill bit. A little bit more oil. Line up the hole for the divot. And we're through. Okay? So there's our second hole. Okay? So before I change it, I know I've got to do a flush sample too, so I'm just going to go ahead and do all of these. So I clean the drill bit out, a little bit of oil, line it up, clamp it down tight with your fingers. I'm feeding very gently, letting the material exit the drill bit flutes. Take a temporary rivet, stick that down the hole, clean the flutes again, a little bit of oil, line it up, clamp it with my fingers, and we're through. So again, this is the sample that if you sit here, Haley, right? Watch out, okay? Because like people will not hold on tight and it'll start getting hot and then that thing will fling out of there, okay? So just be careful. All right, so now we take that bit out, put it back where we got it. Now, the other size hole that we need to drill is a 33. So we're going to take a 33, and because we already have that pilot hole, this should be pretty easy. And I'm not going to have to move my drill press. I'm just going to move one of my blocks out of the way since I used 2 blocks. And since I've got my temporary rivet in there, it's going to lock it all in place, and I should just be able to drill this. A little oil, clamp it down tight, line it up with the hole that was already established. Chloe, you want to grab my tubing that's over there on my bench, please? And then I check, thank you, I check to make sure that this is going to go through. And the tape kind of always gets in the way a little bit. Feels a little snug. Let me just ream that hole a bit. Instead of going bigger, I always try to like just kind of ream the hole to make sure that it's going to go through. Our drill bit gauge gets a little worn out too, so that could be, feels a little tight. Let's just double check that. So we said that was a 33, right? Let's see here. 33 is a little tight there. 32. Let's go 32. I feel a little bit better about 32. So, and again, better to drill, under than over. The key to a good rivet, as we mentioned the other day, is to have a really snug, tight hole. Okay. Let's go 32. Also, I didn't mention it, but I never trust the person before me to put the drill bit back in the right hole. Normally, I would check each time. I know this is a new set and no one's used it, only a few people. So I think I can trust it. But in the future, as we get to working, you need to make sure to even double check the drill bit to make sure it's the right size by sticking it in the drill bit gauge. So that's kind of reamed that hole a bit. Now let's see if that goes through. Yeah, that's going to go. It's snug, but that's really good. Okay. So we line up our other hole, a little bit of oil each time. Don't forget, write that down. Oil each time. Okay. And that temporary rivet kept everything in place. And now we can kind of clean up our area. Don't forget to write that down too. Clean up your area. Put our lid back on, oil. This gets really messy over here if you don't like sweep up after yourself. Alright, and then we can put the 32 back. Now, one of these samples is going to be flush. So what do we need to do? Do you remember what that was called?
Countersinking.
Countersink. Yeah, good, Oliver. That's great. So we need to create a countersink on one of these samples. So I think I'm going to make my flush one. Actually, I think I'll make my flush one this one. Okay. So to create the countersink, we need to go up 3 sizes or 2. I'm going to go 2 sizes. So a 33. If I was a 32, I'd go 32, 31, and then I go 30. So the big hole is going to get a 30 for my countersink, and both sides of the sample will get that countersink. And I'm just going to touch it. Now watch this. It's just like barely touching it. And I'm looking down inside the hole to see the bevel that I'm creating. Now I'm going to flip this over and do the same thing. So you can kind of see there's a bevel. I'll pass that around so you can see that. There's a slight bevel that's created for countersink to create a shoulder for that rivet to sit on. Okay, and then our other size hole, we had done a 47, right? So if we went 47, 46, 45, on the little one, I'm going to go up 3 sizes. So I'm going to go to 44. Okay. sample works its way around, I'll put the countersink on it, okay? See that slight bevel? You can kind of see the way there was like kind of a sheen to it, right? And you just got to be careful. I've had students with the countersink bit be holding it, and they're like, doop, doop, and all of a sudden it grabs it and it sucks it all the way through, and now they've got a giant hole that they can't fill with the rivet, right? Okay? So it's like touch, 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 real light, you know, with
Are we putting 2 rivets in each sample?
yes, 2 rivets, and one's going to be solid and one's going to be tube.
Okay.
So yeah, each one is getting two rivets. You just want to make sure you don't. This is what people typically do. They put both their wire rivets, their solids, in one, and then they have to sand one flush, and then sand around the other one. And I'm trying to make it easy for you, so that you only have to sand one sample completely flush, and it's the one that has both tube and wire.
Gotcha.
All right, so now we can take our other smaller hole, and we'll just touch this down against it. Same thing, we just kiss it. All right, great, we got it. So now we take that out. And the countersink, you know, since I've already established those 2 holes, I didn't have my temporary rivet in there when I did that. That's fine. I don't, you know, it's already, the hole's already been established, so you'll be fine. So. All right, let's go back. So, a couple things to write down. Thank you so much. A couple things to write down. So, when we start making work, and we're working on your projects, there will be sometimes be a situation where, you know, you're preparing to rivet something, and when I drill the hole, inevitably I wind up, especially between the samples, I wind up with a burr. There's a burr on there. You can run your finger across and it's like really rough. And if we leave that burr there, the sample will never truly sit flush with the other piece, okay? So you need to remove that burr. One way in which you can do that is you come back and you know, put down some sandpaper and you sand this, okay? But I want to show you another method that you can use. You can take a drill that's slightly larger, and just in your hand, you can kind of like hold this, and no, I'm not pushing very hard, okay? But I'm basically like removing that burr by twisting that drill bit in my hand, and it deburrs it without having to like scratch the surface completely up. Okay? So it's a neat little trick. You know, I've seen students take a file and then file and scratch the whole surface up. I'm like, man, just take a little bit larger drill bit and just deburr it with a lot larger drill bit. I need a slightly larger than that. Oh, it still has a slight burr on it, but. So, I like to clean those samples up, and it's fine to sand it. I'm actually going to sand this one just to make it a little cleaner. Okay, so the moral of this is that when you get ready to rivet, it's not like you just like drill a hole and just stick a wire in, okay? You're going to prep the piece, you're going to drill the holes, then you're going to come back and you're going to do a little finishing work. Okay, just write that in your notes that you need to come back and kind of finish that sample down a bit. I'm just going to clean that up, that surface. you can even see where there's like an outline where I haven't sanded that enough, you know, like it's still kind of, it's not consistent, right? So we'll need to hit that a little longer until that gets completely clean. See that, how there's no halo around that? No halo around that hole anymore. And I'm just going to go ahead, just for fun, and go ahead and do the other side too. Make sure it's clean. So, you know, later on we start making work. Order of operations is really key. I'm gonna really stress that. It'll be like unlike any other class you've ever taken, where it's like we will plan out every step when we start working on our bigger projects, because the projects are complex, right? Like there's so many nuances to finishing and making an object in this class. It's not like a painting class or drawing class where it's like, you know, I don't know. Maybe they're that way too. I always just think that everything we create, there's so many layers to it, you know? Not just physical layers, but like layers to the process. So we need to start planning out, you know, like, okay, when are we going to do these different things? Now, think about this. If you were to make an object and you were to drill holes in it for rivets, and then you want to deform it, what's the problem with that? Huh? Well, if you one of the things that you do, let's say you made something and then you rivet it and then you want to form it, it'll probably pop those rivets out when you go form it. Now let's say you went ahead and drilled it, but you didn't rivet it. And then when you formed it, those holes will no longer line up. So it's like knowing when to do what, right? So if we're going to form something and form something else and then bring it together, we have to bring it together as formed pieces before we drill it. And we're still probably going to wind up, you know, doing some finishing work after the fact. So for example, if I wanted to patina this, I would probably drill the rivets for it first. Then I'd come back and patina, right? Because if I patinaed and then I drill, then I'd scratch this thing up trying to clean the hole. You see what I'm saying? Like, you gotta figure out all these, like, it's like a giant chess game. I think that's why I always liked metals, was it was like a game of figuring out when do I do certain things, okay? So this is gonna be my raised sample. And I'm gonna go ahead and kind of, you know, prep both of these at the same time. I hope that doesn't confuse you, but I like to just kind of do all the same activities at once. Are you guys starting to understand like why order of operations is like so important? Yeah, okay. I'm going to introduce our next project in the coming weeks. And it is, like I said, it's going to be a much more complex project than that ring. It's going to be something that should be like the best work you've ever made in your life, okay? Like that's always my goal, is that you walk away from this class with a portfolio, 2 portfolio pieces from our 2 major projects that are like, well, bam, you know, like amazing, okay? And that requires combining multiple processes into one piece. And again, that's why figuring out the order that you do things is really, really important. Okay, that looks good. Now, I'm not going to be picky on these particular samples about a specific grit of sandpaper finishing. I just want the rivet to look really, really good. So I'm going to be picky about the rivet and how the two pieces of metal come together, but the finishes, I'm not going to be, like, you don't have to have that same at the 600 grit temperature, okay? All right, now, the one thing I need to do is I need to make sure that I remember and pay attention to which side has my countersink. I'm going to pass this so you can see, you'll be able to see the ledge. This is the top side. And then this is the bottom side, but I'm going to flip it up so you can see the countersink, okay? So see the countersinks in there? Okay? Alright. So now, while the flush sample's coming around, I'm going to start working on bringing together my raised sample. Okay, now, we talked about this the other day, and I said you need to cut a rivet that has about 1.5 millimeters sticking out on each side. Alright, so when I say 1 millimeter sticking out on each side, we need to know how long to cut this rivet. And I talked about two common mistakes with the rivets, right? One is the hole is too loose, and the second thing is the rivet is too long. So what I do is I usually stick out that 1.5 millimeters times 2, right? So 3 millimeters on one side, and then I mark this on the other. Okay, so I kind of like stick out all the material on one side, and then I mark the other side flush. So right, we've got 3 millimeters over here to account for 1.5 millimeters, okay, sticking out. And then I've marked that with a Sharpie mark. Now, on the wall over here on this left-hand board, there's a gray tool to the right, lower right corner, and in the middle there's this like black thing in the middle. This tool right here that I have in my hand hangs inside that little hanger. And this is called a tube cutting jig, okay? Tube cutting jig, but we can use it for wire. Now, the way this works, you're gonna have to pay close attention to this, okay? There's a knob back here we loosen, and it lets this fence slide in and out. There's a lever that you flip open, and then there's a V-block in the middle. So the idea is that you insert your wire, flip the lever over to hold it in place, and then line up your Sharpie mark with the slit that's in here. Okay, there's a slit. That's where our jeweler saw blades are go down. And then I move my fence over, butt it up against there, and then I tighten this down. So if Oliver's making something with 100 rivets in it, and it was the same material, same gauge thickness, he could cut 100 rivets quickly by putting it in a tube cutting jig. You notice I rest this ledge on my bench pen. Let's see if I can catch this. Sometimes I'll use my catch tray to make sure this doesn't fly out. Okay, so there's one rivet, all right? And then I can just move this over, and I know I'm going to need another rivet for my other sample. And I usually cut extras just to have, because inevitably I'll drop one. Thank you. I'm going to go ahead and cut my tubing. My tubing should be the same length. Now the tubing will be a little bit tricky. When you start cutting, it'll cut easy, but then when you get through it, sometimes it catches. And if it catches, I'll cut on the forward stroke, and it'll cut easier without catching. In this particular case, I'm using a 2/0 blade, so it's easy to cut. Inevitably, the thing that most students do wrong is they don't get the rib the right length, okay? And then they wind up with lots of extra material or too little material, okay? It makes it hard to rivet. Okay, so we've got those, and now we are ready. I'm going to make sure they're clean. In between, I'm going to use my flat pliers. That's key. Get your flat pliers out of your kit and use those to hang on to, because I don't know anybody that can hang on to these little things unless you've got some crazy nails that you can hang on to things with. And you get that hole lined up. And sometimes when you deburr that, you might wind up with the hole being a little snug. It actually kind of puts a burr down in there in the middle. I don't think I have that problem here, but sometimes I'll have to take the drill bit just by hand and just kind of ream the hole if the rivet's not going. Now you can see how much we've got hanging out there? That's what we want, okay? You see that? It's a little tough, so stand up here if you can't see and look. Okay? Okay, so now we're going to take what's called a riveting hammer. These hang on the second row, left-hand side. Okay, looks like this. And we're going to put the metal down. And you're going to notice that I'm going to float the surface of this. I'm not letting it contact and be flush. Okay, so look up here for a second if you can't see. If I just started hammering this right now, all 3 millimeters are on the upside. It's not going to rivet. It'll fall apart. So I have to float this. Now, some students will take a thinner gauge metal and actually put it underneath it here to kind of space it. You can do that, but you got to make sure you get the right gauge. This isn't really the right gauge for that, okay? So what I do is I usually get down kind of on level with the block, and notice that I'm floating the surface. I'm looking at the rivet, making sure the rivet is touching the metal underneath the surface plate, and I'm floating this off the edge of the block, and then I'm going to hammer that rivet. Okay? And then I flip it over. Now I'm going to reposition while it's still a little loose. That already got really tight. And I'm going to flip it over and I'm going to do the same thing. Notice I'm out here at the end letting the hammer do the work. And I'm not beating this into submission and beating the rivet down into it, okay? I'm just tap, 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 okay? The other thing I want you to notice is that when I strike this, I am hammering this perpendicular. Inevitably, I will see someone hitting like this, and it's like they're doing this. Well, guess what makes contact? This makes contact with the edge of the metal instead of the sheet, instead of hitting the rivet squarely on top, okay? That's a strong rivet. Like, I can't rip that apart already, and that's what we want. We want a raised rivet where we can run our finger across it. It's a little sharp. I can show you how we can clean those up later, but that's what we want, okay? Everybody got that? Okay. I'm going to go ahead and put in the one for the solid wire for the flush rivet, making sure that I have my countersinks facing out. that one's going around. That's a very nice rivet that I just did there, if I do say so myself. And again, you'll notice it's not hammered into the surface. It is simply flared. Alright, and then I'm going to do the same thing. The operation is exactly the same, except I probably can hammer a little harder with the flush rivet because we know we're going to bury it down in the countersink. So I'm floating that off the surface. Notice I'm hammering a little harder. And sometimes when people get ready to rivet, they'll actually put tape around the surface of their sheet metal. Especially like if we were doing anodized aluminum or something like that. We don't want to scratch the surface. We would hammer with a little tape around it to keep from, doinking the surface of the metal. Spreading that rivet a lot, and I'm kind of hammering it down in that countersink. Then, thank you. Then what I can do on the flush sample only, okay? Make sure you are distinguishing the two samples in your notes. On the flush sample, I can come back and I can file the head of that rivet. Once I've hammered it down in, I can file the head off. Okay, so what does this tell you right now if in terms of order of operations? If you had made a sample and you put a patina on it and then you decided you were going to do a flush sample, what's going to happen? Yeah, you're going to scrape up that patina. So is a flush rivet the best thing to do on something that's already been finished? No, right? So in this case, if you're doing a flush rivet that you want to disappear, you would not go ahead and patina before you put it together. But in the case of a raised rivet, you would. You'd go ahead and do all your finish. You could even wax the piece before you bring the two pieces of metal together, or 3 or 4, how many ever you're bringing together. And we file that down, and I'm just getting this close so that I'm ready for my next rivet. And inevitably this is going to get scratched up. We're not worried about that, okay? So you can see how we're scratching that up a little bit. All right, now let's go back to the other sample. So for this one, I'm going to use my round nose pliers, okay? Do not take this and grab this with the tube. You're going to squash it, right? It's amazing what students turn in. The stuff will look mangled. It'll look awful. And it's just because they are so aggressive. So we're just going to use the round and the round pliers, and we may have to kind of align this a little bit to get this to go in, right? Because it's kind of pivoted a little bit. So that went through really cleanly. And again, we have just the right amount sticking out, not too much, not too little. See that? Equal amounts on both sides. That's what I'm looking for. I'm looking to make sure that everything is equal. While we're at it, I'm going to go ahead and put this one in our flush sample. May have to align that a little bit. That went in easy peasy. Okay, so there's our flush sample. Now, 2, if we took this hammer and we started beating on it, it's going to look awful, okay? It just would never work, okay? So what we're going to use is what are called these tube setting jig, okay? Tube rivet tools. And there's a little wood block, and then there's 4 samples, or 4 punches. So what I do, you can use the block if you want to hold these. Some people do it that way. It's really up to you. I personally like to use a vise. I'm just going to show you how I usually do it, and I'll show it both ways. Some people will take and put the tapered punch, the most strong taper, in a vise like that, okay? And then they take this, you set your tube on that, and then you set this like that, and then we're going to not use a riveting hammer, right? Because that's only supposed to contact non-ferrous metal. But now we're going to use a chasing hammer because we're striking another steel tool. Okay, yeah, good. Write that in your notes so you remember that. Keep this level. Okay, now this is kind of hard to do. I'm going to show you how you can do it one-handed, or one person, I mean. So I just kind of hold this like this. I'm going to wait till you guys get that written down. So it's important that this stay flat, you know, perpendicular. And then I can just take this and lightly flare that, okay? I recommend that when you're working on a piece in the future, especially your projects, that you get an extra set of hands, right, from somebody. Ask for help. Now you'll notice that if it's not held tightly, it'll be a problem. So that's why some people like to use the block, because the block won't move. And then you can do the same thing. I'm going to put this in the middle so it doesn't tip. See how you can flare that? And then I'm just going to make sure that it's equal, because when it's not tight, you can kind of move the rivet in and out. Okay, and now that we have that, then I'll switch and put that one in, and I look for the next one that's slightly less tapered. And again, I'm going to hold this kind of in my hands. Don't be afraid to ask for help. Like, this is something that, like, if you need help with, Maggie and I will be available, correct, Maggie, to help out. So what's happening is, as we do this, see how it's progressively flaring it more and more? It still doesn't look consistent though, right? Like, it doesn't look, right, it's a little rough. Okay, and then we'll switch out, and then you can see this one has hardly any taper at all. Let me put it on here. That was hard to do since it's so flat. And then we'll flip to make sure that we're getting this consistent. If I can get that to sit there. And then once we get that kind of that flare started and it's folding the lip over, then we can come back with our riveting hammer and we can make it look consistent. And again, I'm not hammering it down into the surface. I'm just folding the lip over. And what I'm looking for is a nicely folded rivet. If the rivet's too long, the rivet will split. It'll actually create a little cut, and then I'll downgrade for that. If the rivet is not round and it's all mangled, I'll downgrade for that. Like, I want this to look really professional. Like, see how my lip is a little bit high still, so I'm going to fold that just a little bit more on one side. And that's what the raised rivet should feel like, okay? All right, questions about that? So now we'll do the flush. the key is to get this centered out, you know, so that you get equal amounts on both sides. That's the other thing I'm looking for. I don't want too much rivet on one side, not enough on the other. That's why I always stop and flip it so that I can adjust, so I can get the flare started. Some people like to anneal the rivet ahead of time, especially the tube, because the tube's a little harder. So they'll actually cut the tube and then go anneal it, and then pickle it, and then rivet. And it goes really easy when you anneal, but I always am like looking for like a little speed, you know, so I don't have to like worry about messing with it in the pickle and having to dig it out of there. And again, you'll notice with this, I'm going to hit a little harder since it's our flush one. Sink it down into that countersink. Now we're folded pretty good. Now do the rest with the riveting hammer. Once you get the fold started, then you can come in with the riveting hammer. Now this one, I'll come back and I'll file. Rivet gets finished off with sanding. The raised rivet, that's it. That's done. You know, I got a little scratch there. I wish I didn't have, but. What's cool about this whole process is that when you get done with the flush sample, you start to realize that depending on the rivet, notice that on the brass side, we wind up having a polka dot, right? And we have this clean, I might need to sand just a little more, see that little flange that's on there? It's a little bit of a lip I need to remove off of there. But then on the flip side, look what happens. That rivet's gone, right, on the copper side. We can't even see where it is. A slight little indication, I need to sand just a little bit more. But it should disappear. And then even the tube, you wind up with what looks like a hole, but it's actually the rivet that just ground down flush, okay? All right, questions about that? So in the end, when you're all done, you'll come back to your sample, you'll clean it, and then on the back side, whatever you consider the back, whichever way, you'll write your name. Maybe. Right, and you can turn this in. Right, so that's what we're looking for. It's a nice finished sample, a raised sample, and a flush sample. Okay? Alright. Do you see how this can serve two functions though? It can be a purely functional aspect of a piece, right? It brings multiple things together using a cold connection. And the second thing is it can start to become a decorative element, right? It can be a part of the actual aesthetic or the design of that object. And that's how I want you to think about it in the future. Right? There's nothing to say that we couldn't use that tube as a position, that tube rivet as a position for us to put a jump ring through, and then we put a chain on it, and now we've got a wearable pendant, right? So just keep that in mind as you're working on this sample, it could turn into something else, later on, okay? All right. I think that's it. I think that's all we need to talk about today. I just wanted to show that. So there's no questions about any of that. Seems pretty straightforward. Feel like you can do that? Yeah. Okay, all right. So today, I'll try to get around to the folks that I haven't talked to yet about their rings and their ring research. And then the rest of you can start getting your materials together. The wire is here. The tube is here. You're at an advantage, right, that you know the numbers if you wrote the numbers down, and you can also use my temporary rivets right now as well. So feel free to use anything that you need here, but we have plenty of wire, plenty of tube. You may need to cut the ends off of one of these that's kind of pinched, but it shouldn't take you too long. Once you get your things all stuck together, how you want them, and your center punch mark, laid out, you should be able to do this. So I would try to do this. Don't delay on this. I know you want to get your ring going, but I'd almost say start on this first so that it's all fresh in your mind, okay? Because you're going to forget this otherwise. It seems simple, but there's a lot of steps, okay? No questions. That's good? Yeah? I covered it thoroughly now. Okay, all right. I think that's it. So the rest of the class is going to work, and I'll come around to each person I missed the other day, okay?